So this is going to go on the same channel that I have on YouTube. So if and whenever you feel like you want to listen to it again, go there. Okay? It's recording as we speak right now. So example 1, a string of 12 inches long. Oh, well, that's supposed to be spacing right there. Long is to be cut into 2 pieces. One piece would be shaped as a square, and the other would be shaped as a circle. Part A, express, which is right, the area formula. So express the total area A enclosed by the pieces of string as a function of the length x. And x is what, guys? That's right. Okay, x is the one side of the square. So what shapes are we making? A square and a circle. So we're going to make a square and a circle. What do we label the side of the square? X, right? Perfect. Question number 2 is, what is 12? 12 inches, what is that? What is that going to represent in our application here? What is 12? The perimeter of both, yeah, okay. So 12 equals perimeter of square plus perimeter of what? Yeah, perimeter of circle. Do we know the formula for the perimeter of the square? Yeah. What is it? 4x's, right? So perimeter of the square, would you agree, is 4x? Do we know the perimeter of the circle?
Yes.
What?
It's 2 pi r.
Ah, circle. Perimeter of a circle equals 2 pi r. Would you guys agree with that?
Yes.
Here's my question. If you have 12 inches total, you have already used up 4x for the square. What's left over for the circle?
12 minus 4x.
12 minus 4x. Can we all agree with that? Whatever's left that you're not using for the square, I'm going to take it. So 12 minus 4x equals to the remaining length for the perimeter of a circle. True or false? Yeah, okay. So you can go over here, and if you can see, but I'm not interested in perimeter. What are we interested in? Area, okay. I want the area formula in terms of x. Well, area of the square is just x squared. True or false?
True.
Area of the perimeter is what?
Circle.
I'm sorry, circle. Area of the circle is?
Pi r squared.
Pi r squared. But the instruction said I want the total area with what variable? In terms of x and only x. You have a problem. You have this r squared right there. What are you going to do?
Substitute.
Substitution. From what?
4x. 12 minus 4x.
Ah, there's another equation. Oops, that has r in it. And it's this little guy over here. Okay. So you would have to take that and do what?
Isolate r.
You're right. Divide both sides by 2 pi. Okay. So now I'm going to do, okay, r equals, can I simplify 2's, by the way? Can I take out 2 and reduce that? So that's going to be 6 minus 2x divided by pi. Someone confirm that for me? Yeah, so I'm going to plug it in to my area formula. Area in terms of x is x squared stays plus pi times big quantity, because I'm about to plug in r in there, r squared. R was founded by using the perimeter formula on the left. So 6 minus 2x all over pi. Can we simplify one of the pi's? Because on the bottom, technically, don't we have 2 of them? So always simplify, and then we'll box that up. Okay, so that means I'm canceling one of that means I have 1 left. Okay, so that's what I mean. So quantity 6 minus 2x, just on the top now, square, and the bottom is no longer square, okay? And then that is, I don't require you to FOIL that out, okay? But if you love foiling so much that you can't resist, you can feel free to FOIL and combine like terms. but I don't need you to. I'm gonna hold on tight so you can ask questions. These type of questions are pretty difficult, so if there's something that you don't get, I need you to voice it, okay?
Wait, why doesn't the pi cancel out at the bottom with the other?
Oh, because I have the whole quantity square, right?
Oh, okay.
There's 2 pi's in the
So is that our answer, the one that's highlighted?
That is the formula. It says express the total area in terms of x. So that is your area formula in terms of x, and x is the length of a square. Another question that you have? Okay. Now part B says, what's the domain of A? Well, domain, you're looking for what? X. What x could be? What does x represent? Yeah, so it's really asking, what side length can you have to make your square? So what's the smallest length can you have for the square? Yeah, when you agree, anything bigger than 0. I know yesterday some of you try to cut those squares very, very small. It was very difficult for some of you to fold up your box, but some of you try. So anything bigger than 0. Anything bigger than 0. What's the biggest length can you have? Is it infinity?
No.
No, because you have how many inches of rope? 12. So what's the biggest?
6. No. Or 6 divided by 4.
6 divided by 4. At most 3, non-including 3. How come we're not including 3?
Because you still have to have some for the circle.
You're right, because I had to make 2 shapes, okay? I can have 2.95 for the total perimeter of the square. I still need to leave a little bit for the circle. So non-inclusive at 3. Okay, I will also take 0 to 3 if you like to write it in interval notation. All right, this is where you're going to have to take out your calculator and practice. Graph A, which is really A of x, and then answer the question, for what value of x is area A smallest? What do they mean by A equals A of x? What do they mean by that? Graph A equals A of x. What do they mean by that? Do we know what A of x is? We don't? Are you sure? Yeah, we do. Where? We found it, didn't we?
Yeah.
That guy's right there. Okay? So it will always ask you to graph something that you have found. All right. Hit y equals. Punch it in. Y equals. Enter that in. Okay. You want to practice this as we go along because I can definitely help you today. Once you have entered that equation in, and you hit window, and if you don't have a calculator, please walk down and grab one like this. Hit window. You found the domain already. Okay? Your domain will be used in the window under the x min and x max. So under x min, we should always put the minimum required for your domain, which is what? 0. X max will be at 3, and hit zoom fit. Once you know your domain, you can always use zoom fit. Help each other out if you guys are stuck. Hit window. Okay. Everyone hit window and do from x min 0, x max 3. We're going to use your domain and then hit zoom fit. Now, can you talk to each other? Help each other out. If your friend doesn't have what you are looking at, then help them out. Good.
Or scroll down.
Help out your friend, guys. Unhighlight this one. If you enter X minute X max manually, then Zoom Fit will give you the size. You guys all okay? No, change the window for me. Good. This is what I want. Zoom Fit. That means you entered the wrong equation. Check your white list. Alright, let me see. Yes, that's what I'm looking for. Nope, that's not it. Go back to. Did you enter x squared? You got 6 minus 2x. The whole quantity squared divided by 5. Okay, so using the window. Zoom it. All the way down. You guys okay? It should look like that.
Are almost the exact same.
Did you have quantity around 6 minus 2x and then square? No. Go back to your y equals. You got x squared plus quantity 6 minus 2x plus quantity squared divided by 5. You have a little window? Oh, that's the change your window from 0 to 3. Do we all have something like this? This is sort of what we want to see. The reason is this. Anytime that you're able to find the domain, use that as your window, x min and x max. And then Zoom Fit will give you a really nice graph. You don't have to kind of like, fish around for it. If it doesn't give you the domain, then you kind of have to guess and check on that. So in your homework, when it says graph it out, feel free to use your calculator. Now, so we're going to sketch it. And yes, I want you to sketch it on your homework. What should we label the x-axis in the term of this context? In this application, what does x represent? Length of string? Yeah, would you agree it's the length of one side of the square, okay? Length of one side of the square. What should we label the y-axis? Area, you're right. Okay, it is the area. And based on what I looked at all your, and all I need is just a sketch from your calculator. I don't need the values to be exact. Now you're going to use your calculator and give me I want the smallest area. How do we use a calculator to give us that number? Good. Okay. I want you to give me the x coordinate and the y coordinate. How about round to 2 decimal places? And then we'll write a complete sentence from those values. So second calc. Okay, so everyone find second button and then go to calc, or which is trace. So hit second trace. Because I want the minimum, are we looking for I'm looking for the smallest. Is that minimum or maximum? Min. And do you guys remember how to trace it from algebra 2? Yeah. Talk to each other. If you are not comfortable with the calculator yet, help your friend out or ask your friend. And then round to 2 decimal places. Just to keep it consistent, really. I'll shuffle your card and then I'll ask you to Okay, x coordinate on your calculator. What did the calculator say? What x equals? Sophia, what did x say on your calculator?
1.68.
All right, 1 point what? 6.8, thank you. And then the y should also say it, okay? So Alexander y. I have 5.04. So in an application, I would like for you to give me a complete sentence. As you can see, this question did not say what is the smallest area. I will highly likely ask for that, so let's just practice that. So the smallest area is what? 5.04. Since we don't know, wait, what was the unit of measurement? Inches? Inches square, When the base of the square is, or the length of the square is? When the length of the square is, and something similar to this. It doesn't have to be word for word of what I'm writing. And then inches. And that's how we use the calculator to help you out, so you don't have to do all of the basic math on your own. All right. Example 2. Let P, which is a random point called x comma y, be a point on the graph of y equals x squared minus 1. Part A. Express the distance, d, from your point, which is the random point, to the origin as a function of x. And then B, C, and D said, what is d when x is 0? What is d when x is 1? What is d when x is rad 2 over 2? And then there's another part at the bottom. So first, let me ask you this question. Y equals x squared minus 1. What type of curve is that? It is a parabola. Let's sketch it out. Do we know what this parabola looks like? Where is the vertex? 0, 0, negative 1. Okay. Where are the two x-intercepts? 1, 0, and negative 1, 0. Okay. So that's your curve. It says you have a random point. They didn't give you the location of this P. So P can be anywhere. So for the sake of simplicity, I'm going to write P right here, which is just random x, y. No big deal. Okay. And because in this notes, just because we're going from the distance to the origin doesn't mean it's always to the origin. Technically, this distance can go to any point. Okay. So it says, give me a formula, a distance formula from this point. By the way, does this point have to be where we put this point? No, it can be anywhere. Okay. So from this point to the origin as a function of x. So what do you think we need to do? What should we do? You're right. Let's start with the distance formula. Distance formula from just the other day, it was x1 minus x2, close it up, right? Square, plus y1 minus y2, close it up and square. Do we have 2 points?
Yeah.
Yeah, one of it is vertex. Are you sure?
Origin.
The origin. One of it is the origin, right? And then one of it is just randomly x comma y. So we will write x minus 0 square plus y minus 0 square. Would that be correct? Can I simplify that further? That's just simply x squared plus y squared. But you have a problem. We have a problem. What variable is in here that we don't want? I do not want the y. I want all of my inputs has to be what? The function of x. How do we get y squared out? Well, if I square both sides, then db squared. How do I substitute y? How can I get that out and just put stuff that's on the x's? Substitute with what? You would have to substitute, but now with what? Just like earlier, right? We substitute r. Same thing. You have to substitute y. But what do we know? What is y? Huh? Where'd you see that? Isn't that what y is? Isn't y equals? It means y is that? Yeah. They gave you y in this particular case. Okay. So y is that. So all we do is substitute that in and then y is x squared minus 1 and then close it up square. So now let's verify that one more time. Is that everything in terms of x?
Yes.
Yes, and then we can close that up. If you want to FOIL and combine like terms, can you? Yeah, I'm not going to stop you. You can. Okay. Part B, what is the distance? D is the distance to the origin when x is 0. How do we find that answer? Plug it in, right? So d of 0 is 0 square plus 0 square minus 1 quantity 0. What's your final answer? 1. Let's check it with the graph to see if it confirms. When x is 0, is that the vertex? Yeah. And let's just count really quickly. From the vertex to the origin, is that a distance of a total of 1?
Yes.
Yes. So our algebra is right. Our graphing looks legit. Why don't you and your team try C and D together? And then we'll just call on 2 students to give me the final answer. If you have an answer to C, verbalize it. Hey, I got this. You guys hear this? Make sure it's right. Did you guys verbalize with each other about C and D? Yeah, thank you.
Oh, that's fine.
So C, your team gets what? 1, and then D is on your team.
C is 1.
What's round 1?
So this should be square root.
Square root of 1 gets into that. Square root of 1 is always 1. Yeah. Rationalize. Good and good. Perfect. Yeah. Good. And perfect. What's square root of 1? Good and good. Perfect. Good. Yeah. 0, 2. Good. So as I'm walking around, pretty much every team has common answers. Letter C, everyone has 1. So the distance, okay, it's 1 unit, right? 1x is 1. And then I saw that a lot of you had, oops, I just gave the answer. Rad 3 over 2. Okay, perfect. Now let's use a calculator to help us out. Using the graphing calculator to graph the function d equals d of x. What does I mean by that? What's d equals d of x? Is what function? Did we find that already? Did we find that d equals d of x function again? Where did we find that? What part? What part of the problem was that function in? Part A. All right. So go to y equals in your calculator. Find part A. Punch in that equation itself. So from part A, you have a function. What does this right here for us mean? X must be greater than or equal to 0. Well, where would that go? That's your domain. So I want your x min to be 0. X max is not stated, so that means you have to kind of play around with x max.
So we're graphing x squared minus 1, or we're graphing
So we are graphing d equals d of x, and then whatever that you found, okay? And typically it's always like the first couple steps of the question. You need to tell me. What are we graphing? Read it. What are we graphing? What is d equals d of x? It's always what you find. There's a reason why you have to find it. Graph it. Okay. Anybody have an x max yet that you like? They give you an x min, which is 0. Anybody found an x max that is somewhat reasonable? For 15? 5? Okay, 5, 15. Try and mess around with it. Today is the day for you to kind of mess around with the calculator. Get more support if we are rusty. That's good, yeah. Lots of you have good graphs. 100 is probably way too big.
Yeah.
Three fourths. Oh, there you go. we have to subtract that first. So subtract 1. Subtract 1.
That's still wrong.
I know there's just something in there. Square that first.
Okay, there's still something wrong.
I had to square that. I was like, wait, I couldn't. I know, because it was so like.
Looks beautiful.
I know.
Look at the
I
wrong
was like,
way.
a couple times too. No, thank you.
There's something wrong.
All right, here's what I want you to, because I know a lot of you are messing with the window, which is perfect. You're supposed to do that during the notes, right? Can you try x min, obviously 0. Can you try x max around 3? So 3, just put 3. And then do zoom fit.
When you set your x max to 10,000, so your y axis is just a straight line.
Yeah, you don't want that. That you won't be able to see very much. If you do x max 3, you can see a little bit of a divot to where you can see the lowest point, right? So if you do x max at 3 or near 3, then you see a little bit of better. So again, anytime you enter x min and x max manually, do zoom fit. It will give you a better graph. Looks good. And then this question says we need to find a local minimum. Okay, so let me find my pen. I saw lots of you have. Did I leave my pen at somebody's station helping you guys? No, my Surface Pro pen. Oh, thank you. See, I knew I left it. Thank you. Okay. Because this one has restrictions, class, and I think a lot of you I saw, this one doesn't start at 0, 0. Would you guys agree?
Yes.
Yeah. It starts somewhere here, and I don't need an exact graph. It looks like that. Okay. We need to label the x-axis. What should we label the x-axis? Distance or just x? Just x. Y would be the distance. All right, here we go. And then you trace for the minimum. Can somebody give me the 2 points for the minimum? What did you get?
0.71.
0.71. And then what was the y?
0.87.
0.87. So how would we state this in a complete sentence that is applicable to our question? The what? The what? How would we state this to where we interpret this value to where it's applicable? This is definitely a local minimum, but back to this applicable question, how do we state it? What's a complete sentence we can use? The lowest, what? The shortest distance to where? The shortest distance to the origin. Remember, that was the original statement, right? To the origin is 0.87, right? Units. It didn't say units. Would you guys agree? When x is? Yep. Okay. So this is what's called optimizing. Optimizing meaning finding the smallest or the biggest. Okay. Yesterday's activity was finding the biggest box. So that's also finding the max, which is also optimizing. So tonight's homework, your video will have example 3 and 4. example 4, the assignment 5, we'll do in class, okay? Anybody need help with the calculator? Make sure you attend tutorial, guys. Okay, return my calculator if you borrow one. Again, if you guys are rusty with the calculator, come and see me.